This is the second part of the data preparation tutorial video for CPA. Today I'll talk about functions that can help you find and fix problems in the data. I'll start by opening the sample file I used in the first part of the tutorial. In this video, I'll work with the data2 corpus. It is different from the data3 corpus I used in the first part of the tutorial in several ways. First, this is longitudinal data from a single speaker. Second, we have the utterance type column that provides additional information about the data. This column is not important for us right now, but since it is part of the corpus, it will be retained during data preparation. Finally, we see that the data is not simply a list of words, but contains mostly spontaneous speech. Some of the utterances contain more than one token, even if it is repeated a number of times. So first I need to run the data preparation macro and perform the first two stages. And I'll use CPA's internal tables and specify one sheet. This is a single speaker multi-level time-stamped corpus, so I can use the default parameters for corpus tokenization. And now I'll select the target data and the output data and the age. So now we have the results of corpus tokenization and also the accessory tables. Let's observe the processed sheet, which contains the processed corpus data. We can see a few changes compared to the processed data3 corpus I used in the previous video. First, we see that there are duplicate index values in the utterance column. Tokens that have the same utterance index were part of the same utterance in the original data, as we can see here. Second, because this is a single speaker corpus, unlike the data3 corpus, there is no need for a column containing the speaker's ID. Third, the utterance type column was copied from the original sheet, and I didn't need to do anything to make that happen. Finally, we see that some tokens in the target and output columns end with commas. Eventually, we won't need these commas or other non-phonetic symbols, and there are a few ways to get rid of them. First, I could delete them automatically during tokenization by checking the word dividers option in the corpus parameters form. I can also delete them right now using Excel's find and replace function. CPA has two additional ways to do such deletions automatically, and I'll demonstrate them in this video. Okay, so the corpus has undergone initial processing, and now we can run the final three stages of data preparation to improve the quality of the data. For the purpose of this demonstration, I'll run them one stage at a time, starting with the find unregistered symbols. This stage is important mostly for speech data written in phonetic alphabet. Later on, we would like to run some phonological analysis on the data, so it's important that all symbols we use in the transcription are defined correctly. CPA has a number of tables of linguistic symbols. We have the phonetic table, the phonetic diacritics table, the orthographic table, and the orthographic diacritics table. The find unregistered symbols function examines the data and looks for symbols in the target and output tokens that are not defined in any of these tables. When we run this function, we need to tell CPA whether this is a text corpus or a speech corpus, so it will know whether to use the phonetic tables or the orthographic tables. Then the function is executed. We can see a new sheet called unregistered symbols was added to our file. It contains a list of symbols that were found in the corpus but not defined in CPA's tables. We have the comma and the plus signs, and also an uppercase P. This is because this corpus data is written in IPA, which does not include an uppercase P. It can also be useful to see which tokens contain these unregistered symbols. If we go back to the process sheet, we can see two new columns in it called unregistered symbols target and unregistered symbols output. I'll turn on the filters in the sheet and filter out blank cells in the unregistered symbols target column. So now I can see exactly which cells contain the unregistered symbols. And I can do the same for the output column. After identifying unregistered symbols, we need to do something about them. If we decide that an unregistered symbol is important and we would like to preserve it, we should add it to one of CPA's tables. Let's say the uppercase P has a different meaning than lowercase p. In this case, I can just add it to the phonetic table. Most often, however, unregistered symbols are unwanted. Some of them need to be deleted altogether, and others need to be replaced by something else. To do these deletions and replacements automatically, we will use the fourth stage of data preparation macro, convert strings. This function can do several types of conversions. The first option, phonetic orthographic conversions, allows us to define specific types of conversions. CPA has a pair of tables that are called phonetic conversions and orthographic conversions, in which we can define conversion rules. The phonetic conversions table is used with speech corpora written in phonetic alphabet, and the orthographic conversions table is used with text corpora. These tables have identical structures. In column A, we define symbols or strings that we would like to change. In column B, we specify the new values for the strings in A. For example, the first row in the phonetic conversions table replaces an apostrophe with the IPA symbol for primary stress. When a cell in B is empty, the string in A will be deleted. We can see an example for this in the third row, which removes blank spaces. We usually don't need to define deletion rules in the conversion table to delete individual symbols, because CPA has another way of doing that. The third column in the conversion tables is used to replace specific words. Let's say I want to replace the sequence da by the sequence ta, but only if it is a whole word and not a part of the word. To do that, I need to put da in column A and ta in column B, and also put 1 in column C. Finally, I can limit conversion rules to apply only to target level or output level of the corpus. To do that, I need to write the name of the level in column D. So now I defined a rule that replaces whole words da with whole words ta only at the target level. Note that some strings in column A begin with the tilde sign. Some symbols have a special meaning in Excel, and in order to find and replace them in the text, we need to put a tilde sign in front of them. This is true for asterisks, question marks, plus and minus, and also the tilde sign itself. The @ sign is also a special symbol in Excel, and in general it's best to avoid any of these symbols in phonetic transcription when working with Excel. Let's go back to the string conversions options. The second option changes all uppercase letters in the data to lowercase. We can use it to transform the uppercase P in the data to lowercase. The third option, delete unregistered symbols, simply deletes all the symbols that are listed in the unregistered symbols sheet. We can use it, for example, to delete punctuation marks. Note that the conversion options are performed in the order in which they are listed. So we can convert specific unregistered symbols first, and then delete the remaining unwanted symbols. Next, we have an option to delete diacritics-only tokens. Let's say our data contains numbers with a percentage symbol. The digits themselves are not linguistic symbols, and they will be deleted by the delete unregistered symbols option. But the percentage symbols is registered in the phonetic diacritics table, as we can see here. So it won't be deleted by deleting unregistered symbols. So after deleting digits, we may end up with cells containing only a percentage symbol, which is not very useful on its own. The diacritics only tokens option can delete cells that contain only diacritical marks, but no letters or phones. Finally, the conditioned conversions option performs special types of conversions as defined in the conditioned conversions table. In column A, we list symbols subjected to conditioned conversions. In columns from B to D, we can specify the conditions for deleting these symbols. There are three types of conditions. Deduplicate means that a sequence of multiple identical symbols will be reduced to a single symbol. The beginning condition means that the symbol will be deleted if it appears at the beginning of the word. The end-only condition means that the symbol will be deleted if it appears only at the end of the word. For now, I'll check the first three options and run the convert strings function. After the conversion is done, CPA asks whether I would like to check for unregistered symbols. Use this option to check that all unregistered symbols were removed or converted, and that no other unregistered symbols were inserted by mistake. Indeed, we see that the unregistered symbols sheet was deleted, and so were the unregistered symbols column in the process sheet. So the transcription is now up to standard. Finally, the last stage of data preparation, target output mismatch analysis, is recommended for multi-level corpora. Such corpora contain corresponding utterances, and we would like to verify that each output token is paired with a corresponding target token. If not all tokens are paired correctly, this might affect the results of further analysis done on the corpus. After running this function, I get a message that some target and output tokens are not paired. In addition, a new column titled mismatch is added to the process sheet. I'll filter out blank cells in this column. And we can see that in one row, I have an output token, but no corresponding target token. If I go back to the original data, I can see that in the last row, I have one target token, but two output tokens. And this is why we have a mismatch. In such cases, I can either add the missing target token or delete the entire row, which is what I will do now. Then I turn off the filters and run the mismatch analysis again. So now CPA reports that no discrepancies were found, and also the mismatch column is removed from the process sheet. It's important to know that when some tokens are not paired with a corresponding token, other tokens in the same utterance might be paired incorrectly. So it's important to examine not only rows with missing tokens, but also other rows with the same utterance index. Anyway, our corpus is clean now, so we can save the file and do some analysis on it. In the next videos in this series, I'll demonstrate how to perform different types of analysis on the corpus. Until then, bye bye.